I'm going to be talking today about configuring in my eyes, the perfect Umbraco 9 solution and what you need to do to make that work for yourself as well. This is me. I run a small agency in the UK. I think a few of them are watching. Hello. But you can reach me on Twitter as well. I'm quite active there. I'm a Umbraco MVP 4 times, a Microsoft MVP 2 times, and a .NET developer, I guess by night. Now I'm a spreadsheet person really by day. So what we're going to talk about, when we sat down to build our first Umbraco 9 solution, we decided to just totally reconsider how we were building our Umbraco solutions and architecting them. And there was a lot actually involved. This was an opportunity for us to have a clean slate, reset our thinking, and try and come up with some best practices and things that we would always follow. So I'm going to today walk you through the process that we went through, scrutinizing every little bit of setting up an Umbraco solution. We'll have a look at how we did stuff in V8 and prior, and look at what some of the new shiny things in .NET 5 and also in Umbraco 9 can offer us to make some of these things a bit easier. Of course, we'll first start with templates. Templates are a new thing in the Umbraco ecosystem, but definitely not a new thing in the .NET world. This is this idea that you can have a predefined set of configuration that you can install to bootstrap a project really easily, and that includes Umbraco. So now the recommended way of installing Umbraco and getting started is not actually directly through Visual Studio necessarily, but maybe using the CLI here. So you can use .NET new Umbraco and it will bootstrap an entire solution for you, and all of the the little bits that are needed to actually run an Umbraco solution. You have to install these from NuGet, and to do that you can go .NET new I, which is a shorthand for install Umbraco templates. Now that ::* that you see at the end of the syntax here is really important. This basically says install all versions of that template, and it allows you to do that. Another thing I would say is there is a new version of these templates every time Umbraco releases a new version of Umbraco. This allows them to make configuration changes to the base template every time they make a minor release. So there's one just now for Umbraco 9.2 beta or preview that's available on NuGet. So if you're ever starting a brand new solution, first things first, just run that .NET new I command, because it will get you all the latest templates, and then you can safely run .NET new Umbraco and you'll have an up-to-date latest version of Umbraco installed. It will bootstrap the solution and the project view and everything, all good. There's some really good documentation around this as well. There's countless other arguments you can pass to that CLI. Of course, this CLI is also our way to set up and install packages. In this case, uSync is a staple of every single one of our Umbraco builds, so we would just install that by default too. These 3 commands pretty much get us up and running, ready to go. We can start our Umbraco solution. Now, another thing that's really essential, we use Git heavily. We're working in a team. We want to track all of the changes that we make, and we also want to make sure we're not tracking all the stuff we don't want to track. The bin folder, all of the temp files. A git ignore file is a way that we can say to Git, please don't track these files. Our best practice before was to go and get the Visual Studio git ignore file from GitHub. GitHub maintain a repository of lots and lots of git ignores, really helpful git ignores for different languages and different IDEs. They have a Visual Studio one which ignores all of the stuff you wouldn't really want included, temp data, etc. There's also an Umbraco git ignore. So our typical setup would be that we'd create a folder for our solution, and we drop for our repository, sorry, and we drop the Visual Studio git ignore file right in at the root there. Then we'd create our Umbraco project, and inside the Umbraco project, we'd drop our Umbraco git ignore. So we'd actually have 2 git ignore files there. The reason for that is, of course, Umbraco has some specific things that you don't want to include. In our case, we say we shouldn't really be including the media folder because people don't want to be doing that. It's effectively content. So we would exclude the media folder, also image processor caches and stuff. These are things that aren't covered by that Visual Studio base git ignore that we'd use. So we have both to kind of cover both cases. Here's an example of what that looks like. Like I said, it's all the common stuff you don't really want included in your repo. The app data folder, the Umbraco developer, like the packages folder, which I think is a legacy thing. It's not really a thing in V8. Your out of date flag for models builder. You don't want any of that in your repo. So this just helps keep things a lot cleaner. However, with Umbraco 9, this has changed completely. The Umbraco git ignore, as far as we're concerned, is completely redundant. Umbraco now, when you run that .NET new Umbraco template, it gives you a git ignore, a nice git ignore that pretty much covers everything you'd want Umbraco to cover. You still do need that Visual Studio git ignore file though. So it kind of has taken a step out of the process for us. We first create our repo, we drop a nice standard Visual Studio git ignore file in there, and then we run .NET New Umbraco, and it gives us everything we need, including that git ignore file. Awesome. So where do we start with the project structure? There's going to be a lot of code in this talk, and I know it's a Monday and very close to Christmas, but hopefully this will, hopefully you'll be able to follow this nicely, and I'll happily take questions at the end. Solution structure and what you call things, where you put things, is a hotly debated topic. People are going to have their preferences, and that's absolutely fine. I'd love to hear about them. This is how we build things. So as a typical rule, we've had an app start folder in our pre-V9 projects. We've had an app start folder, and that's where we will keep all of the stuff that happens on startup. So all of our Umbraco composers, all of our components, and that's where we do all of our DI registration and all of that stuff. And we try and split them out accordingly to what their purpose is. So if we have a general global one, we might have one called application composer or startup.cs. Whereas if we had something maybe for a specific section or a specific piece of functionality in the site, we would do the same. We'd have a news composer, and it would do all the stuff for the news section. Equally, controllers, pretty much standard in every Umbraco project, I'd hope nowadays. MVC pattern is what's used by Umbraco kind of out of the box, and that's what people generally follow. So you create a controller for any back-end code that you need to execute on a page. You'd then have a model that you pass along to your view, and that's a way of you exchanging the data between the two, and that's how it all works. So in this case, we generally don't do render controllers. We don't generally hijack the full page rendering. Instead, we usually have a model that we would pass, we generally pass the main models builder model to our views and keep our templates themselves pretty clean. And then for any specific bits that we need, any dynamic data within those pages, we'd use child actions via a surface controller. We'd also use web APIs and stuff to maybe pull data in dynamically if we had a view front end, for example. So our controllers folder generally looks like controllers with a bunch of service controllers in it, and maybe an API folder if we had some API controllers. The models, this is maybe where stuff gets a bit contentious. Models Builder allows you to move where your models live. You can put them in a different location. In our case, we do a couple of things that are slightly different to maybe most. We keep all of our models in the web project. They are a front-end concern as far as we're concerned, so they live in the web project. And we put them in a folder called published content. And that helps separate them out from the rest of the project. They're not bundled in with everything else. We can't modify those. They're generated. We shouldn't be touching them. The one thing we can do, though, is extend them. They're partial classes. So that allows us to add our own properties or maybe implement interfaces that we need to via that partial class. So to avoid those getting confused, underneath published content folder in our models folder, we create a generated folder. And that's where we tell models builders to dump all of the generated classes, and then we keep our partial classes for anything we want to extend outside of that, and we can then do any modifications we need there. We also set the namespace of those models, so we use that as an opportunity to kind of brand the models builder models to match the namespaces in our project. Just keeps things nice and consistent. And then you've got a really nice namespace for your published content models, so you can go project.models.publishedcontent.homepage, and you've got access to your homepage model there. The other thing that lives in this models folder is something called a partial model. It's what I'm going to call a partial model. This is where maybe if you're returning a list of items, and those items, that the object that represents that, we'll call a partial model. And that's not something that would be a view in its own right, but it's maybe a little bit of data inside a wider view model. And then speaking of view models, we have a view model. We'd also have any forms that need submitting back to the page. They'd have a view model as well. And then our views. I think this is a pretty typical structure, hopefully. So let's talk about startup in Umbraco 9 because this has changed a lot. Of course, in Umbraco 7, if we can cast our minds back a couple of years, we were all used to doing application event handlers and being able to hook into the application starting, all of those sorts of events and do whatever we needed to do. In Umbraco 8, that model changed completely, and we went with this composer model. In Umbraco 8, they were called user composers, if you remember. Well, now in Umbraco 9, we still have composers. They're just called an iComposer instead. This is an interface you can implement to do whatever you need to do on startup, including register things in the built-in DI container or execute custom code if you need to. If you look on the right-hand side here, you can see an example of a composer. It's all pretty simple stuff. However, this is actually an abstraction, a wrapper around what .NET does out of the box itself, which is something called Startup CS. This is a class that ships with every .NET core application, .NET 5 application, and it allows you to configure the application, define all of your settings, register things in the DI container, all from one place. Umbraco has kind of wrapped that with their composer concept, but you can do everything you can do in a composer pretty much inside the Startup CS and vice versa. From our case, we're preferring to go down the composer route instead of modifying Startup CS. This might seem a little odd. Why are we utilizing not the kind of native .NET stuff to be able to do this? Well, the reasons are the heavier that Startup CS file gets, the more difficult it's going to become to maintain. In our case, if we upgrade the solution and Umbraco maybe needs to add a couple extra things into that file, we're going to have to manually go ahead and visually merge and compare the differences there. Whereas if we have them all utilizing Umbraco's abstraction, the composer, we can have them split out all nicely how we need them. We can see them very clearly in our project. We can easily track changes over time. They're not going to get broken when we do an upgrade. And yeah, it all works. The alternative is putting these kind of things in a static extension method. So you could have just one line in your Startup CS that says add application, and it would do everything that your application needs to do within that static method. But we're preferring the composers in this case. It also keeps a bit of familiarity for devs, being able to work from Umbraco 8 and 9 in a similar way. There's another slightly more hardcore option here, which is called a startup filter. Now, this is a pure .NET thing. If you, maybe as a package dev, in fact, wanted to modify the Startup CS, add your own stuff into there that isn't an Umbraco flavored thing, perhaps you want to register some custom middleware, you can do that with startup filters. So this iStartup filter is an interface you can implement. It comes in .NET. On startup, they'll scan for those, they will load those in and execute them, and you can then do whatever you want to do. This is exactly the same as the other two examples. So you have access to the service collection, and you can register your own dependencies there. You can, as I say, add middleware, register configuration, do everything you need to do. There's a few packages that are already using this in the Umbraco sphere. I know uSync is doing similar as a way of people not having to modify their Startup CS file. So let's talk about view components. This is probably the biggest change that we found in the way that we work, because historically, as I said, we used surface controllers with child actions to render dynamic content within our templates. Child actions are a thing of the past. They don't exist in .NET Core, and the new concept is called a view component. The reason we were architecting our solutions the way we were, having a controller, a specific method that then returned kind of a view with, I've got some code in fact, you see on the left here, a controller, it's a service controller. We can then return a view that we desire, and it can have any data we want passed into it in a really clean way. It keeps logic out of our views. It keeps things as simple as possible. As I've said here, it keeps your UI componentized, or your front-end layer componentized. Yeah, they've gone in .NET 5. View components is the new way to do that. And they're pretty much exactly the same, except whilst the surface controller is an Umbraco concept and all they're doing there is wiring up all the stuff to render a child action, in this case, it's a pure .NET thing. So actually, it's a bit better. We're moving further towards how .NET wants us to do things. The one thing that bugs us a little bit is where they live. So by default, your view components, they live under views shared components, the name of your class, and then the name of your view, which if you've not supplied one is just the word default. Now you can imagine if you're trying to build up a library of components, that becomes a little bit difficult to follow. It makes total sense why this exists, but maybe in the kinds of websites that we're building, it doesn't fit so well. So we've looked at all kinds of options here for trying to move that path, and it's really not that easy. You can register some other folders for it to look at. So if you don't want your view components to live in views/shared, you can register some things at startup that say, hey, maybe put these in partials/components. But the bit on the end is what really irks me. The view component name/view name. Not really a huge, not really a nice solution. So we'll talk about how we've got around that in a few places too. I showed you this a second ago. This is a surface controller on the left-hand side. This was pretty cool. We could inject anything we wanted into here. So an external service to go and fetch some data. We'd then have a method that we call to render, and we could then return a view with a model. And that would render by default in views/shared/my component, in this case, the name of the component. But you could pass a custom view path in there. It could be absolutely anything you wanted it to be. Now with view components, very, very similar. Hopefully this code looks almost identical. Instead of inheriting from service controller, we inherit from view component. We can still inject our own stuff into there. And then we just have a method called invoke, and invoke returns a view. We're doing exactly the same bit of data, getting the exact same bit of data here, and it just returns in this stranger path. You can also execute these async, which is something we didn't have before. So view components, there's also an invoke async method, and you can do all of your async code, meaning if you've got an async service you need to call, you can just call the async service and not have to worry too much about it. So this is a pretty cool benefit of using the view components instead. How do we render them on the front end? Well, again, I think there's a lot more options now with .NET 5, and this works quite nicely for us too. So before, because these were all child actions, we had really handy html.action render my component, which is the name of my method that I defined just here, and you pass in the controller name of where it lives. In .NET 5, that's slightly different. We've got 3 different ways of doing this. Component.invoke, and just giving it the name of the component. They're decoupled from a controller, so you don't have to worry too much about where it lives or what controller it's in. You can just refer to it by name. That's pretty cool. As I said, there's an async version as well. So if you're going to call your code, if you're doing anything with async, you'll need to call await on that in your view, and then you can call invoke async, your component. That's great. And then the one extra thing, which is a really nice addition in .NET 5, is razor helpers or tag helpers. So you can have these HTML style tags in your markup that you would then decorate with, in this case, VC my component. I can refer to it by its name and load in a view component in kind of HTML style syntax. So every view component already ships a corresponding tag helper as well, which is pretty sweet. So I said we weren't happy with these paths, and we've done something a bit different. Our use case here is when we're rendering something like the block list, we've got a list of components, a list of modules, let's say, and those modules, they all have a custom view, and they would all have a model coming from Umbraco, a content model. However, sometimes we want to put some custom content in there too. We want to pass a custom view model, and previously, we could do that by having an action for every single one of those, which is a bit cumbersome, but not fantastic. But what we can now do is we've actually created this base view component that we can use pretty much everywhere. So we created a block list item view component, and that then routes all of these block list items to be served from a very, very specific path. So in our case, partials, modules, the name of the module .cshtml. And it just passes the content model straight through by default. But what we can then do is we can check to see if a view component exists by name. So in our case, you can see here, we've got a custom block list renderer. And what that's doing is when we're rendering the block list content, we check to see if a block list exists with the same alias, the same name as the content type alias we're trying to render. And if it does, we'll use that block list component instead. And if it doesn't, we just fall back to our default block list view component. This allows us this flexibility. We can have a custom view model passed to our model. It all still lives all in the same place. It's all nice and consistent, but It's completely different logic without having loads of repeated code. Oh, there was one bit I wanted to talk about on here as well. So service controllers aren't going anywhere though. There's a slight disconnect now where previously if you had a form, you would render that as maybe a child action and you'd be able to render the form inside a partial. And then you'd have another method inside your surface controller to handle the submission of that form. However, because now view components are kind of a singular thing, they have no publicly routable methods, whereas a service controller does. If you need any logic that, say, posts back to the server, example, a contact form. If you had a contact form previously, we could have had a contact form controller with a method that renders the form and a method that handles the submission. Now we have a view component and we still need to have a corresponding surface controller to handle the posting back. It makes a little bit more sense because they are separate concerns. One is rendering, one is handling ingress of data. However, it does make our solution a little bit more confusing. We've got two files now to ultimately do the same thing that we had previously. I just wanted to quickly talk as well about injection into views because that's something new in .NET Core as well. We can now inject dependencies directly into views. So perhaps this would be a way of keeping your views a bit cleaner. Before we would have had to have newed up instances of anything we wanted to go and fetch. So be it the Umbraco helper or be it the a custom service. In this case, a custom service that probably takes config as a parameter. Now you can register that in your DI container and inject it. So at inject custom service would give you that custom service. You can use it in your views. Helps keep things a lot cleaner there too. You could have also done it with the service locator. .NET 5 does not have a service locator built in. Umbraco is not giving us a service locator. We're really being encouraged to use dependency injection for everything. So either you keep your views nice and clean by using view components, define custom view models, you pass those off and you have those living in their own partials, or you could use the DI container to inject stuff and make your views a little bit cleaner too, just clean the logic up there. Let's talk about Razor compilation too. So a really important performance gain that you can get is by enabling compiled views in Razor. There's a few problems with this though. Firstly, if you're using the models builder mode in memory auto, which was the artist formerly known as Pure Live, I think it was in V8. We don't use it, but if you are using that, you will not be able to use compiled views because if you change your model in any way, it will not match what the view is expecting. Otherwise, if you're compiling code and probably like you should be, turning this on should have no negative side effects, except for maybe some packages doing weird things in the views. You might get a bunch of errors in your console when you build, but this will give you fantastic performance gains by enabling this. It means that the runtime doesn't have to in memory compile your view every single time. It's just there. It ships a nice views.dll with your application. If you're a bit unsure about this, maybe you don't want it on locally so that you can have freedom to develop and do what you want. You could enable this directly in your CI pipeline as well. So in this example, I've just put the same bit of XML into my CS proj file, but with a condition on it. And my CI server can set that condition to be true. If it's got a value, it will use that. And if it hasn't, it will use my false default value. Umbraco includes these properties by default in the CS proj file when you use the project template. So you don't have to worry about going and adding these, but they are set to false. So consider going and setting these to true and make it a checklist item for yourselves. Right, let's talk about configuration because there's also some big changes here. And this is probably where we get the most benefits out of what's changed in .NET Core because we can start using some of the new shiny things that have been there for a little while now. Appsettings.json, we're all familiar with the web config file. That's what we've had in .NET Framework for years and years and years. Horrible XML-based config. It's massive, really, really massive. Appsettings.json is your new friendly web.config file. It does everything that the web config file did, kind of, but better. It's effectively the main appsettings.json file is your main configuration of your application. But you can then have partial files on top of that. So environment transforms, for example, rather than the exact file being munged together with, the base file and your environment file, you instead, it will do that at runtime. So it will say, well, I'm running in this environment variable with this environment variable set, and it will take the settings in your development config and override the ones in your main app settings JSON config. This becomes really, really powerful. So you could treat your app settings JSON as your constants, all of the stuff that's not going to change regardless of which environment you're running on. And then you can have these different files that only apply as and when necessary. So in our case, we've decided that app settings JSON has very, very little in it, only the settings that we need on every single environment. The development JSON has, say, a local connection string in there for what we need to run the application locally, has a few different models builder settings too, which we're going to have a look at in a second, because these allow us to turn off models builder generation everywhere other than when we're running in development mode. And then production, that's your release config. But a word of warning, just like with the web config, don't store your secrets in this file, and there's no need to, because the new .NET configuration options actually allow us to inject secrets and keys at runtime. So you don't need to worry about in your repository storing this massive production JSON file. Let's just keep the crucial application configuration settings there, and let's find a different solution for storing keys, which we'll have a look at now. I mentioned models builder. We do this slightly differently. In-memory auto is the default. As I said, it will break your precompiled views. Most people, I would have guessed, working with Umbraco will want C# classes and class files that they can actually interact with directly in their repositories. So we use source code auto as our default option, and we set that in our appsettings.json file as the default. Source code auto in every single use case. Also before, whilst the files would get generated into the app data folder where they couldn't actually be compiled, now they get generated into a folder called Umbraco/models, which sort of makes sense. Umbraco owns those models. They are serializations of entities that exist in the Umbraco database, so it kind of makes sense that they live there. So we enable source code auto and let the files get generated into that Umbraco/models folder now. On the non-dev environments, we set the models mode to nothing. Like this. So this is our app settings JSON. You can see we've defined a custom namespace here to keep it nice and friendly, and we've set it to nothing. And on development, we override that by saying use source code auto as your configuration option instead. This allows the basically only in the development environment is that turned on. Everywhere else, models builder won't generate anything, but the files still use the default path where Umbraco wants them to live. Anyone using uSync? I suspect so. Most people probably are. Now, uSync Content Edition in Umbraco 9 is enabled. It's bundled and it's enabled by default, which may not fit your workflow. It certainly doesn't fit our workflow. So by default, that means anytime you save a content item, you'll get a nice serialized file, an XML file on disk that is for that content item. Equally for languages, dictionary items, the lot. It does a lot of stuff. We want this disabled by default. So we've put some base settings in our configuration as well that say, yeah, let's turn that off. There's a few ways of doing this. You can specifically say to uSync, hey, disable these 5 handlers. So if you wanted to have dictionary still enabled, but you want to get rid of content and media, you can do that. Disabled handlers, content handler, media handler, list them out, and that's all good to go. This just goes straight into your app settings config. App settings JSON, sorry. There's some other options too. So if you maybe want to be a little bit more broad in the way you turn things on and off, uSync has a settings object that they ship as well, where you can add this bit of JSON to your configuration and say, these are the groups that I want to enable or disable. So in this case, we've said only export the settings group, and that means content types, data types, member types, etc. And then the UI enabled groups, those are the only ones that are visible in the UI too. This would allow us to effectively eradicate the content option from the UI for a user, and there's no way developers will ever be able to trigger it. This is particularly helpful when you're using some of the add-ons for uSync. So if you're doing vendor and you have vendor uSync, you can supply a comma-separated list here. If you want to say, well, I want to be able to export settings, but also vendor, you can just say settings, comma, vendor in both of those cases. Launch settings.json is probably something that people don't know exists. It gets bundled in with all of your projects, and it's a really handy way to make sure your team is all working in a consistent way. Why does this matter? How many people have used a shared database when they're working with an Umbraco site? You perhaps have a dev server, and the database lives on that dev server, and 2 or 3 devs all connect to the same database. It causes countless problems, but people do it, and sometimes it can't be avoided. However, people end up with slightly different configuration options for running it locally. People spin it up on maybe a different port or with a dedicated host name in some cases. And also, if you're working with multilingual sites where there's 2 or 3 sites, they have different host names, having your project shipped ready to go and saying, I can respond on these 3 host names is really handy. So everyone's working in the same way. Launch settings.json is included in your project, and you can do everything you need in there. So this is where you can define your launch profiles to say, when you hit that big green button at the top in Visual Studio, what happens? What actual commands are you going to execute? In this case, I've got 2 examples, one for IIS. If you want to run your application in true full IIS instead of IIS Express, you can do that here, and Docker as well. And you can then set which environment variables you want to use. So you could have a specific appsettings.docker.json with some specific config for running when you're in Docker. You can set your host names, you can set countless other things to execute as well when you configure this. And finally, I wanted to talk about Ioptions. This is one of the most exciting things, I think, coming from .NET Framework. This is a complete revolution in the way configuration works internally in .NET. And it's something that we can be using throughout our applications. Ioptions is a out-of-the-box way to store and ship configuration in .NET. It allows you to register at startup, register a class and say, this is a configuration class, and allow it to be injected. So in our case, we would do this in a composer, but you could do it in startup CS or in a startup filter. You would say services, service collection, .configure, give it a type, and then you'd pass in an I configuration section, maybe something from the web config. In my case, I've taken a custom section that I've called API keys, and I'm now mapping it to that my API's iKeys class. You could also do this all nicely in line with this builder pattern as well. So you can go configure of type options and then physically set the values yourself if you really wanted to. And this is handy where maybe you want to override something that a package does out of the box. So the package would have this line in it, the get some settings out of the app settings file, but you would probably want to override that in your application, and you can do just that. So you would, in your own code base, have services.configure, and you can start really controlling how the applications register stuff. And then how do you use it? If in this case, if you had some custom API keys you wanted to ship around, I've got a service here as an example, and I just inject Ioptions of T, Ioptions of my API key, and then I can call options.value, and that's the instance of my API keys class with all of the values set coming straight out of the web config. This is infinitely easier than it was in .NET Framework, where we had to be parsing XML manually ourselves, or creating hundreds of classes to do this. It's really, really straightforward. You could also use something called iConfigure options, which is an interface you can register, and again, .NET will find it at app start, and it will pull that in and configure the options for that type for you. This is really cool because if anyone's very security conscious and maybe doesn't want any secrets being shipped around in their configuration, yeah, you're onto a winner here, because we can inject anything we need inside this class. So in my case, I'm creating an instance of Azure's Key Vault secret client. And from that, I can go and fetch secrets out of Key Vault at runtime. So when the app boots up, I'm configuring my API keys with values from Key Vault. No one has ever seen what the keys are. only the application knows what they are in this case. So this is a really nice, pretty simple way of doing things. Previously, people would have done this with some custom code that maybe sticks them into memory on app start, or perhaps would have called them every single time they wanted them from Key Vault. This is way more efficient. This is way safer as well. So you can use the configure options interface to be able to do that. There's also a thing called named options. So this is incredibly similar in principle before, but perhaps you need different versions of keys per different versions of configuration per something in your application, per site if you had a multi-site instance, or perhaps per section of the site or module or something. So you can register that same class services.configure of T, same type, but with a name. By default, when you do that without the name, it's just registering the name of default. And it's kind of burying all of that magic away. But what you can then do is register like that and inject those configuration options anywhere you need them to be as well. So instead of injecting Ioptions of T, you inject Ioptions snapshot of T, which then has a method on it, get, and you can call get with a name and get your configuration for that, which is pretty sweet. And just like with the iConfigure options, there is an iConfigure named options interface as well that you can implement. And some of our favorite tools use these. So if you need to configure examine with Umbraco 9 to work in a specific way, this is the way you do it. Examine uses the examine uses the named options pattern for all of the index configuration. So in this case, we're doing a check to see if we've got the external index configuration available, and if we do, we can add some custom field and do whatever we need to do. This is the way to be configuring examine. So this is a pattern that you could also utilize in your application. It's something that's familiar for people in .NET 5. All right, so what does the end result of this look like? I've thrown lots of information at you there of how we're trying to structure our solutions, but let's maybe have a look at what a solution would actually look like in practice. So over here, I've got my Umbraco 9 solution. It's pretty simple. I've not really got anything set up. You can see I've got my views, a home page, a news listing page, a few partial. Actually, I don't have any partials. That's even better. I've got a couple of view models, some simple things here. I have inside Umbraco, I've got my models builder models, hero block, and homepage, the only content types I've created currently. And under models, I've still got a published content folder for homepage because it's a partial class that I'm extending. I've not actually done anything here, but I could very easily add, a new property, page title, for example. So that's extending the default models builder class there, which is cool. I've got my partial models as well. So this is this news listing item that sits. It's not a view model, but it's not a content model either. I've then got some controllers. It's pretty simple, and these components that I mentioned as well. You'll see down here I've got an appsettings.json file. It doesn't have any secrets in it. This is using default production config. There is no connection string here, crucially, except if we look into my development one, there is a connection string. Well, there isn't because I removed it, but there would be a connection string there for you. Let's have a little look about the block list component stuff I was talking about. So here, this is our block list view component that we're using. This lives in our components folder. So we have components and controllers. We named it components so that they sit next to each other specifically, because if they were view components, they'd be way down the bottom. And our problem, as I said, with things like a contact form, where we need to have a view component for rendering the form in the first place, but a controller for handling the data being sent back to us. That's why we just keep them close together. So it's a little bit easier to follow. We've played around with having, a folder where we have a controller and a component in the same folder, or two classes in the same file. We just felt this was a lot clearer. For the block list, as I said, we've got a base block list view component that we use. In our case, this is what it's doing, and then we can override that. So I've got my hero block view component that extends that class, and then I'm implementing my own view model that's different to the one that the block list is sending by default, which is the content itself. And that's it in a nutshell. I would love to know what your experience is with configuring Umbraco 9 and how you've found tackling some of these challenges, because I'm sure everyone's got preferences, everyone's got their own flavors of how they build solutions too. So let me know. I'm on Twitter down there at the bottom. I'll happily also answer some questions now, but thank you very much for listening. And again, thank you so much to Henk and Arnold and the entire DukeFest team for putting this event on with so many challenges. Thank you.
Talk about .NET Core and .NET Core Plus, really, and Umbraco 9, obviously. I have one question from the audience for you, and it was triggered very early on in your talk, and it was about choosing child actions over render controllers. What is your reasoning behind that?
It's a fantastic question. So, like I said, we try and keep our templates as clean as possible. So my idea is that the outer template should really just be a bit of markup and then calls to the relevant components. And it helps keep your UI componentized. Now, those could be partials. So instead of it being rendering a child action, it could be loading a partial in. So you've got, nice separation. It's nicely split out there. However, then you end up with messy partials where you don't have you have to do all of your building of all of the data inside the partial. And then it kind of makes sense to say, well, we'll put that in an action and keep everything there. So if we keep thinking on that basis, the outer template should really be quite dumb. It shouldn't do anything other than rendering those bits of UI components that exist on the front end. And then the child actions themselves are where all the complexity lives. That's our thinking. Keeps it modular.
I see. I also noticed in your project that pretty much everything is inside a single project, whereas if you would look, for example, at Umbraco, there's a .core and a .web. They separate out the different logic. So what is your reasoning behind having that as one thing together? Why mix your HTML with your CSS classes?
Yeah, sure. So in this case, I try to keep things incredibly simple for the purposes of a demo.
Okay.
If I showed you some of our other projects, you may be horrified at the number of projects that are actually in there, because we do quite a lot of separation of concerns and stuff. But I think everything I've showed in that solution, we would still keep in there. So our components would generally be included in the web project. Our models builder models would stay in the web project, and if we needed to access anything off those models builder models elsewhere, we would create an abstraction around that, so an interface or something that we could consume outside of that project. I know people have, and we've done it before, put their models builder models in a separate class library, and that's quite a good solution too. But generally, we treat anything that's for front-end render as a web concern, and it lives in the web project, and any business logic lives in an implementation project of some sort.
I see. So does that mean that if you take the model builder models, obviously sometimes you have things in your backend logic that uses these models as well. Would you say that you usually create an abstraction on top of those models before you use it in your backend logic, or do you immediately use those published content models pretty much?
Yeah, so in this case, we'd have a core project, and there'd be an interface that lives in that core project. And you would implement via that partial class on the models builder model, we'd implement that interface. So effectively, the models builder model then conforms to that interface. And it means that we can call Umbraco's content cache and say, get me that item, and say, is it that interface? And it does, it conforms to that interface. And then we use effectively that interface as our contract throughout the application rather than the generated model. Meaning the interface doesn't change, but the content model can. If someone changes something in the Umbraco CMS, that's absolutely fine, but the business logic's not going to break.
I see. Well, pretty clear explanation. Also, thanks from the audience because you answered that first question. One last thing from me. At some point, you were talking about the app settings and the models builder, and that you want to disable that on the production and basically any environment other than your development environment. Something I noticed myself is there's also an enable option on the app settings. There's an enable and there's a models mode. And you explained about setting it to nothing, which is obviously the right choice. I just wanted to mention for the viewers that do not use the enable option, because the enable option literally does what it says. It disables models builder, as in if you then run your project on an other environment than your development environment, you don't have model builder, so the pages don't recognize your models, and then things break
the
down.
Content cache no longer returns the models builder models. They're all iPublish content, just raw iPublish content.
Exactly.